Hi there, welcome to this new tutorial. Today we are going to do something exciting. When you have built everything that is in this tutorial, you'll have an apparatus that actually does something on its own, and you can later build the rest and have an actual computer. Last time I showed you the register, the 4-bit register, and I put the files in the Github, which I'll mention again. The bottom of this board has a number of pins, and I listed them here. If you fix it so that you have 4 of these boards on a base plate, the pins will stick out in the bottom. And here are a couple of slides to see how they connect. As you can see, the ins and the outs of all the 4 boards are connected. This seems a bit strange, but because you have the control electronics, they don't work at the same time, so it's okay to make actually a loop of those ins and outs. I'll show you now the finished work, which is on the board on the right upper corner. So for demonstration purposes, I disabled the control part of this computer. Instead, I'm going to hardwire. I have 2 wires here, which are both positive, and I attached to the bus a machine that helps me to input a value. It's now set at 12, I believe. So what I'm going to do is press A in and hope that the register selects that value, 12. Okay. Now I'm going to do A out and ALU register 1 in and ALU register 2 in. So A out, and they're over here. 1 and 2. Now if this register is a special one, this is a general purpose one, here you can decide whether you input it or output it. This one is special because it always outputs the value to the ALU. And here is another register, the ALU out register. If I activate that, it should adopt the value 12 plus 12 should be 24. Hope you can see it, but it's 24. So another demo. Again, in the manual mode, I have number 5 on the board. I'm going to load that into the A register. A in, there it is. Now I disconnect this. Let you know that the only number 5 is in the A register. And now I'm going to do A out. ALU 1 in and ALU 2 in. A out. Sorry. A out. And there it is in the ALU registers. Now I'm going to put it forward to the ALU out register, and we get 10. So for the final demonstration, I activated the control electronics again. The computer is running at 10 Hertz. And this time I'm going to get the data from this apparatus. It is programmed to give out a value, one to the first ALU register, the other to the other ALU register, and you'll see that after that the ALU out register lights up with the correct value. So I'll change the values. And we wait a little, and then it adds up correctly. I'll change the data again. And again, it does it correctly. Last time. Again correctly. If it works by manual control, it for sure works with automatic control. Now I'm going to discuss a very practical matter, how to solder all these tiny wires. First of all, I found a wire that is really thin. I call it angel hair. It is AWG 26, and it has a very thin coating as well. Now it's easy to solder one wire to a pin, but if you would like to solder a second wire to the pin, the first will set itself free. So the trick is, if you need to have two wires, is to twist them together and solder them together. And there's a different trick if you want to connect 5 pins. What you do is you take 5 wires, twist one ends to each other, cover it with shrink wrap, and then you have 5 endings which you can individually solder. Here's the actual bottom of the board you just saw in the demonstration. It looks like beep, but it really works, and it keeps on working as well. It's actually quite sturdy. Now I'm going to show you a personal situation I had. My breaking point on why I use PCBs. This is a decoder, a 64 decoder, and I was halfway wiring, and I thought, well, this is really impossible. And I have to confess, I don't give up easily. But then I went to EasyEDA and JLC PCB and designed this board. 2 of these boards are exactly the same as the board you saw before. It's so much easier. There are so fewer wires and also fewer incorrect soldering. So I'm really happy about it. For every tutorial I make also a presentation, which I put in Github, and there's a easy explanation of how to use EDA and how to go to JLC PCB. The design I just sent to them is a base plate for a general purpose register. Let's say the drawings you just saw, but I first have to test it before I make it post it on GitHub as well. It will take 3 weeks or so. Well, this is for this episode. I'll see you again in 2 weeks approximately. A special thanks to JLC PCB for sponsoring this video, and special thanks to Ken and Kelvin. Bye bye!